So is 100,000 years and 100,000 light years in diameter, and 2,000 light years thick. And I'm going to give you, I will give you an exact proportion to show you. This is if you were to shrink the Milky Way galaxy to the size of a DVD or CD, they both have the same proportions. This would be 100,000 light years wide, and this small width of it would be 2,000 light years thick. That's how it would look. Milky Way galaxy is a medium-sized, slightly smaller medium-sized galaxy, than other galaxies. Slightly on the small side, but slightly. This location of the Milky Way galaxy is very important because it protects us. We're 26,000 miles from the center. That's approximately 2/3 from the center. We're on the Orion. It's called the Orion Perseus spur. It's right at the edge there. It turns out in the center, and the reason why it's so bright is because it's a concentration of stars. It looks like it's solid, but these it's a concentration of stars, and average distance between stars is 7 light years. A light year is 6 trillion miles, or 10 trillion kilometers. So they're very far apart. Even these are very far apart, but they look like they're solid because there's so many of them, millions of them. It turns out in the very center of the Milky Way, there's a black hole, which is a result of a star that's 8 to 10 times bigger than the sun collapsing in on itself. It forms what's called a singularity. A space, infinite smallness and infinite density, and the mass of our black hole is equivalent to the mass concentrated of 3 million suns. So what they do is they spin in a black hole. It spins around. They call it a black hole because light can't escape because the gravity is so powerful. But around it, the suns are spinning around and they're breaking apart. They're pulling the suns around, pulling the suns apart. And when they pull the suns apart, it's like a hot superheated gas going around the center. And the superheated gas gets so hot that it emits gamma rays. Okay, so these gamma rays from the center, they shoot out very powerful and lethal up to a distance of 20,000 miles. At 20,000 miles, it disperses a bit, but not entirely. But we do have a shielding of, they call it dust and gas, hydrogen gas. And dust is the remnants of, it's not the dust you see in your house, it's the dust of exploded stars. Stars produce metal, iron, in their cores, and that's what they call it, dust. You could see some of this is dust and gas here because it's dark. And so we have the dust and gas, a lot of them at 20,000 miles from 20,000 light years from the center. That absorbs most of it, but not all of it. So the rest of it dissipates. All right, but the good thing about it is, as we're circling, as our solar system is circling in this part here, and it's circling counter from this direction. It's circling counter. It's not circling this way. It's circling counterclockwise. Our solar system is circling around at several 100,000 miles an hour. We can't notice the motion because we're Newton's law of inertia. It's like you could stand up on a moving train. You're moving with the train, so we're moving with the Earth. So that's why it can go very fast. And that's why when Copernicus said that the Earth goes around, he formulated that the Earth goes around the sun, and the Earth is spinning. Galileo said the same thing 60 years later. That's why people objected to it. They said, how do you do that? Church steeples would fall down, buildings would fall down. That was before we had Newton's laws of inertia. So we know better now. So it's circling. But a good thing about circling is when our solar system circles is going around our galaxy, there's stars above and below our solar system. some are very big, and they exert a lot of gravitational force. So our galaxy, as you can follow the laser printer, can you see it? It's right above where it says our Milky Way galaxy. This is the way our Milky Way galaxy is going, and we're traveling right now. In many lifetimes, it goes like this. It goes up. It goes up and down, up and down, up and down. So because of the gravitation, as it traverses the distance, it's encountering the gravitational pull of bigger stars. It's called gravitational torquing in the scientific term. But the good thing about it is, remember our light, the thickness of our galaxy? 2,000 light years thick. It never goes above or beyond that thickness. It stays within the cushion. If it were to go beyond the dust clouds, if this were a dust cloud, let's say this illustration of a horizontal dust cloud, if it were to go out, it would be blasted by deadly radiation. But it stays within that cushion. That's another example of divine design. Does anybody know how we can figure out how our Milky Way galaxy is shaped? How do we know that we have arms like that? Anybody do tracing in elementary school? You trace a leaf over it. You take a leaf, you have paper over it. They could do that by the structure of our Milky Way galaxy is done by radio telescopes. Radio telescopes were developed in 1930. And so what they do is, all galaxies contain mostly hydrogen. This is hydrogen interspersed with young stars. Young stars are bluish. This is hydrogen. Hydrogen is within the empty spaces too. Hydrogen is heated up by stars. And when they get heated up, they emit radio waves. And these radio waves are in the 21 centimeter range. The wavelengths are 21 centimeters long. So they take these radio telescopes and they position them at various points in the sky. Where they receive the strongest signal, you get like this, where the stars are concentrated. Where you see weaker signals, you get mostly empty space, although there's lots of stars in there, but compared to this. And that's how they do it. And these radio telescopes are as big as a football stadium. They're in New Mexico, they're in South America, they're all over the world. That's how they determine nowadays how they determine the distance of the planets. They have these big antennas in their radar. And they shoot it at Mars, and that's how it's done. You know. Another thing, star clusters. Star clusters tend to be, and you can see star clusters with your telescope in your backyard. Star clusters tend to be a little bit above the plane, a little bit below the plane. Not in the plane. And that's good, because if they were in the plane, they would be dangerous. So the radiation from star clusters above the plane are dispersed horizontally and not within the plane. Now it turns out that our galaxy is, in turn, we talked about how the Earth is positioned just right, is protected by Jupiter and the planets. You know, the moon stabilizes it. And it turns out that our galaxy has a special position. Our galaxy is on the outskirts of what's called a Virgo cluster of 50 galaxies. Galaxies are grouped in clusters. It's just like cities are organized. You have the central city, it's crowded, and then you have the suburbs, and then you have the countryside. Well, we're in the suburbs. We're part of the Virgo cluster, which is around 50 galaxies. But it turns out that we're sort of at the edges of the Virgo cluster. We're not real close up. Anybody know the advantage of that? You ever been in a crowded elevator and get bumped by people? Okay, well, all these other galaxies that are in the Virgo cluster, they're close enough to each other because they're being bumped around. What happens when they're bumped around? We've seen this. Astronomers have seen this. The gravitational force, it's called gravitational torquing. They're bumping around, and we've seen solar systems, we've seen suns being flung out of their orbit by that. we're separated farther enough to keep us safe. We are being bumped around by the Virgo cluster, but it's very slightly. We'll never notice it. So, now it turns out that the Virgo cluster of 50 galaxies is part of the Virgo supercluster, which is composed of many, many thousands of galaxies. And our Virgo cluster of galaxies is separated from the Virgo supercluster at some at a distance. So we're at a safe distance. We're not going to be bumped around. M74, which is basically, it's another galaxy. We think that our Milky Way looks the closest to this. And we would be like around here. See, cluster of stars. Stars in galaxies, the stars that are closer to the center tend to be bigger, 8 to 10 times bigger than our sun. And the problem with that is stars that are 8 to 10 times bigger than our sun, they explode frequently and get high intensity gamma rays, and they also have gravitational pulls, and they tend to knock planets out of orbit, and they tend to have suns go flying away. So we don't have that. Dispersed, where near the end there's fewer bigger stars, but they're fewer concentrated. Yeah. Here's these. Now, I want to show you a couple books. I'm near the end of my talk here. Anybody hear of Hugh Ross? It's called reasons.org. He has a PhD in astrophysics from the University of Toronto. And he's an ordained Congregationalist minister, and he gives speeches on how the Earth is, the cosmos is designed by God. What's his name? Hugh Ross, R-O-S-S. So he goes around speaking at church. He spoke in Buffalo several years ago. One of the books is called Why the Universe is the Way It Is. And he explains it into detail. Another book, Creator of the Cosmos. Same thing, a little different aspects. I got to tell you about this. I got to tell you about this book here. This guy got in trouble for writing this book. It's called The Privileged Planet. His name is Guillermo Gonzalez. He has three PhDs. And there's another guy, in addition to another professional, J.W. Richards. He talked about how the Earth is situated, just as I'm telling you, how it's positioned in a special way that's protected. He worked for the Smithsonian Institute, and he wrote a scientific paper about it. And he said it looks. He didn't say it conclusively. He said it looks like it's intelligent design. The way it's constructed. He wasn't a categorist. He didn't say it was intelligent design. He said it looks like it. The people at the Smithsonian Institute immediately fired him. Now, to get tenure at the Smithsonian means your position is permanent. You got to have a minimum of 15 professional scientific articles published. He had 30 articles published. Whoa. So they fired him for saying that. But they used another excuse. They said that his scientific articles weren't up to standards. They replaced it with an atheist who had a minimum of only 15 scientific articles published. So he's now with the Discovery Institute, which endeavors to look into what's called intelligent design. This is what I've talked to you about is intelligent design. Another astronomers call it the Goldilocks principle. In Alice in Wonderland, the character Goldilocks, she ate the porridge and she said it was just right. That's why they get the term Goldilocks principle. And it's also called the cosmological anthropic principle. Anthropic means man-centered. I mean, things are just right for us. And back to Richard Dawkins, he said there's no evidence in nature that God exists, and if you encounter God, why you make yourself so invisible? So we know he didn't make him. I explained here, anybody could see, that all these things, can't be coincidence. And as we talk about coincidence, anybody hear of Boyle's law? This is the mathematical principle. Anything to the 10 to the 50th power and more means it's statistically impossible. That means 1 followed by 50 numbers. Engineers use that all the time. The space shuttle engineer, they use that all the time. If there's a chance of failure of the space shuttle exploding, if it's a number with 50 zeros, they'll launch it, because it means it's statistically impossible that it's going to explode. Airline engineers use it all the time. So these are I've given you the basic factors. There's actually more technical factors which I don't know about, 120 of them, where things have to be just right in our solar system. Overall, for all the factors to be right, it's like 10 to the 120th power. Wow. For these things to occur naturally, by chance.
10 to the 120th power?
Yeah, for us to be livable. For all the factors in the universe, the gravitate, we go into detail about, the force of gravity has to be just right by a tiny, tiny amount. If the force of gravity was more or less, stars would explode. The forces that hold atoms together, the strong nuclear force, they have to be within very short what's called tolerances. And so, but Richard Dawkins and the other, they persist in saying, "Oh, there's no evidence," because they don't want there to be evidence. They don't want it to be evidence. Because there's one university professor. He believes that Darwin's evolution, everything came by chance. He said, "I don't want God to exist." And so, that's basically the end of my talk. So I hope you can share it with people and remember this.